Hello everyone, welcome to Rasaayana Institute of Sciences. In this video, we are going to discuss about what is degree of unsaturation, also called ring rule. Especially it is one of the most important concept in organic molecules, where we will see whether given molecule is saturated or unsaturated. So indirectly I am saying that whether molecule is completely satisfied or unsatisfied, so that is expressed in terms of degree of unsaturation. So we can also define like this. Degree of unsaturation nothing but see the unsatisfaction of a organic molecule. Unsatisfaction of a organic molecule is expressed in du. Degree of unsaturation nothing but how much a organic molecule is unsatisfied. So indirectly I am saying unsatisfaction nothing but unsaturation. Unsaturation means maybe molecule may carry either a pi bond or molecule may carry one ring. This is called unsaturation. If any molecule carry a pi bond, if any molecule carry a ring, that molecule is said to be a unsatisfied, also called unsaturation. Generally you people think that unsaturation nothing but double bond. That is also right. So this unsaturation is also nothing but a double bond or triple bond. So generally if I take any double bond, carbon-carbon double bond, here there is a presence of one pi bond. And if I take any triple bond, carbon-carbon triple bond I am using now. See, this is sigma bond and here it is 2 pi bond. If molecule carry pi bond, it may be 1 pi bond or 2 pi bonds or 3 pi bond, or it may be carry a ring. Then that molecule is said to be unsaturated. Then what about saturated molecule? This is called saturated molecule. Saturated molecule nothing but the organic molecule having a only single bonds and that too open chain. So best example for saturated molecule is alkane. Alkane generally see, this is called ethane, and this alkane general formula is CnH2n plus 2. It is a general formula of alkane. CnH2n plus 2, it is very important formula. Every molecule when they want to participate in chemical reaction, they want to attain a alkane general formula. Because alkanes are completely saturated species. Saturated species almost all highly inert in organic reactions. So that's why if you compare double bond, triple bond and alkane, alkane having a very low number of chemical reactions as compared to double bond and triple bond. So every unsaturated molecule want to convert into saturated molecule. For that we are adding a hydrogens or we are breaking any ring. That is called ring rule. So what actually, how to calculate degree of unsaturation? See, we can also define like this. The number of hydrogens less than alkane general formula. Alkane general formula. How many hydrogens are less than alkane general formula? That is called du. Is du. So I can say alkane. See, this is alkane general formula. We know very well. CnH2n plus 2. This is alkane general formula already given. How many hydrogens are less than alkane general formula? That is called du. Okay. So suppose if two hydrogens less than alkane general formula. Okay. Remember, if two hydrogens are less than alkane general formula, if you substitute number of carbons in this formula, here you will get actual number of hydrogens. To these hydrogens, given molecular formula having less number of hydrogens. So that is called first two hydrogens less than, that is alkane general formula. So here it is 1 du. 1 du nothing but molecule may carry one double bond or else one ring. It is possible. This is a possibility. 1 du nothing but every du 1 pi bond. 1 du nothing but molecule carry 1 pi bond. In double bond 1 pi bond is there. 1 du nothing but one ring. You need to create molecules. Okay. Next, suppose if 4 hydrogens less than alkane general formula. 4 hydrogens I am writing. Now du is what? 2 du. Degree of unsaturation is 2. When degree of unsaturation is 2, I can say 2 double bonds. 2 double bonds carry 2 pi bond, or else 1 triple bond. See, already given 1 triple bond carry 2 pi. 2 pi nothing but 2 du. Or else we can also take 2 rings. Many possibilities we can write. 2 rings. 1 double bond plus 1 ring. C. Every time this number should match within the organic molecule. 2 nothing but may carry 2 pi bonds. 2 pi bonds, 2 rings, 1 pi bond, 1 ring. And we know that triple bond carry 2 pi bonds. Every triple bond carry 2 pi bonds. So that's why du is 2. Okay. So that is the case. Next. See. If molecule carry, third possibility, 6 hydrogens less than alkane general formula. Then see, this is third degree of unsaturation. Degree of unsaturation is 3 du. So which means it may carry 3 double bond, 1 triple bond plus 1 double bond. Otherwise we can say 3 rings, etc. Any possibility is expected, but remember 3 we need to create. Okay, then possibility will be when 8 hydrogens are less than alkane general formula, then what happens? See, this is 4th degree of unsaturation. 4th degree of unsaturation means 4 double bond, 2 triple bonds, 1 triple bond, 2 double bond, 4 rings, etc. We can go through any other possibility. Okay, so degree of unsaturation also calculate by using this formula. Formula is 2n1 plus 2 minus n2 by 2. This is a formula. It is a direct formula to calculate degree of unsaturation. 2n1 plus 2 minus n2 by 2. Here n1 nothing but n1 is equal to number of carbons. How many carbons present in a given formula? n2 is nothing but number of hydrogens. This formula is most helpful to calculate du in a given molecule. If you are getting du3, apply this one. If you are getting du4, apply this one. And this is the overall formula. It is a gunshot formula to predict the answer whether given molecule is satisfied or unsatisfied. Okay. So, see, suppose if any halogen is present in a given organic molecule, if any halogen is present, because see, here N1, N2 I given only for carbon and hydrogen. Suppose some molecules are there, there is a presence of halogen. If any one halogen is present, every halogen we need to add one hydrogen. Every halogen, one hydrogen. Suppose see, if I take C6H4Cl2. So in this case C6H4Cl2, here 2 chlorines are there, 2 chlorines you add here. Just assume that C6H6, C6H6 like that. Every chlorine just assume that 2 hydrogens, 1 hydrogen. Every chlorine, 1 hydrogen, that will be added here. 2 chlorines are there, 2 hydrogens are added. This is only assumed formula to calculate du. Later on we need to create structure based on these halogens only. Okay. Then every nitrogen here minus 1 hydrogen. Suppose if I write C6H8N2 if I written, in order to calculate du, every nitrogen we need to remove 1 hydrogen and create one hydrocarbon formula. So I can write C6, that is S6. See, remove 2 hydrogens, you will get C6S6. And every oxygen doesn't affect hydrogens. Means there is no effect of hydrogen here. C6H8O. Suppose if I write C6H8O. Or if I take C6H6O, you take any molecule, right? C6H6O or any one. In this one, see, just remove this oxygen, you will get C6H6. No need to add, no need to remove. Okay. So this technique you need to remember to calculate degree of unsaturation within the molecule. Every halogen is equal to 1 hydrogen we need to assume and create one hydrocarbon formula. Every nitrogen, remove 1 hydrogen and create one hydrocarbon formula. This is only an assumed structure to calculate du. But initially we are creating structure based on these formulas only. So I will explain one example. See, first I would like to explain one example with hydrocarbon. Simply see this. Here I am writing C2H4. It is a molecule I given. I want to calculate whether it is a saturated or unsaturated. So first you calculate what is N in this one. N is equal to 2. Then substitute this 2 in alkane general formula. CnH2n plus 2. So if I substitute this 2 in this formula, you will get C2H6. If C2H6, see, If number of carbons substituted in alkane general formula, actually we need to get C2H6, but what they given? C2H4. And try to identify how many hydrogens are differ between given molecule and real molecule. So here 6 hydrogens and here 4 hydrogens. So here 2 hydrogens are less. When 2 hydrogens are less, now degree of unsaturation, it is first degree of unsaturation. Or else it is a first technique to calculate. Other one more technique is there for DU direct formula. So apply this formula. 2N1 plus 2 minus N2 by 2. 2 into number of carbons in this one, 2 plus 2 minus how many hydrogens are there? 4 hydrogens. That is 4 by 2. So 2 into 2, 4 plus 2, 6. 6 minus 4, 2 by 2. 2 by 2 means you will get 1. 1 means 1 du. You can apply either this formula or this formula. Any one you can apply. But right now see, if you are getting first degree of unsaturation, which means first write down carbons by putting single bond. Carbon, carbon, you write down. 1 du means I can write 1 pi bond, otherwise 1 ring. Ring is impossible to write between 2 carbons. So definitely I would like to write a pi bond. So if I write 1 pi bond, remaining will be balanced with hydrogen. See, if I put a double bond here 1 hydrogen, here 1 hydrogen, here 1 hydrogen, here 1 hydrogen. So this is the example for this molecule. Right? You need to remember this. They will give one molecular formula. In that try to separate N. Try to substitute this N in alkane general formula. You will get a real formula. It is a saturated formula. It is a given formula. And try to identify the difference between 2 hydrogens. A given formula and real formula. Here 2 hydrogens are less. I can say first degree of unsaturation. When you get 1, may carry 1 double bond, may carry 1 ring. Okay, one more example I will show. This is C3H6 I am writing. Now, apply first model. N is equal to 3. Now, we know CnH2n plus 2. Then what is the formula? C3. 2 into 3, 6. 6 plus 2, 8. C3H8. C3H8. So, if it is C3H8, here 2 hydrogens are differ. Here 2 hydrogens are differ between these two. So, when 2 hydrogens are differ, this is first degree of unsaturation. First degree of unsaturation. Now, we can also apply one more formula, du. 2n1, 2 into 3 plus 2 minus 6 by 2. 2n1 plus 2 minus n2 by 2. 2 into 3, 6 plus 2, 8. 8 minus 6 by 2, you will get 2 by 2 here 1. So, first degree of unsaturation. Right now, when you get 1 du, which means 1 pi bond or 1 ring. First you write down 3 carbons. 3 carbons I am writing. 1 du means 1 double bond I want to introduce. I can introduce anywhere else. So I can put double bond here. Anywhere you can put. Then balance remaining hydrogens. Here how many hydrogens are required? 2. Here 1 hydrogen and here 3. Automatically you will get this formula. See 1, 2, 3. C3. 3 plus 2, 5 plus 1, 6. C3H6. Suppose, can I create a ring by using 3 carbons? Yes, 100% I can create. So I am writing 3 carbons, 1 ring. This is 3 carbon, 1 ring. 3 carbons, 1 ring is over. Already 1 ring is 1 du. Then balance with hydrogens. See here 2 hydrogens and here also 2. Automatically this formula will come. So with this formula we can create variable number of expected organic molecules which is having a unsaturation. It is also unsaturated. It is also unsaturated. Right? So one more example I will give. This is, suppose see, this is C4H6. C4H6. And if I apply first formula, if n is equal to 4, then what happens? See, C4, 2 into 6. Apply CnH2n plus formula. 2 into 6, like that. Okay. So 2 into 4, 8. 8 plus 2, 10. So C4H10. It is alkane general formula. Here 6 and here 10 is there. How many hydrogens are differ? 4 hydrogens are differ. When 4 hydrogens are differ, second degree of unsaturation. So second degree of unsaturation means you can also use this formula to calculate. See this. 2 into 4, 8 plus 2, 10. 10 minus 6, 4 by 2, 2. Even by using this formula we can calculate here. Now with the help of 2 du, I would like to create some structures. See, write down 4 carbons. Write down these 4 carbons. Du2. Du2 means 2 pi bonds. I can put one pi bond here, other pi bond here. Yes. it is matching. Du matching, carbons matching. Then balance with hydrogens. 2 hydrogens, 2 hydrogen, 1 hydrogen, here 1 hydrogen. That's it. Suppose we know, write down 4 carbons. 4 carbons, I would like to introduce one triple bond. See, because every triple bond, how many pi bonds? 2 pi bonds. Then remaining you balance with hydrogens. Here 3 hydrogens and here also 3. See, C4H6. Suppose can I create one ring? Yes, I can create one ring. 4 carbons, one ring. Okay, Du. Here only one ring is there. 2 Du actually. I can introduce one ring. Automatically hydrogens will balance. If you count total number of carbons and Du. Total number of carbons are 4 and Du if you count you will get total number of rings. Okay. Now see, this is one ring. 4 carbons, one ring, one double bond I am writing. One ring, one pi bond. Like that we can create many structures. See. But number of carbons are remain same. Here carbons are 4. See. Total 4 carbons and Du. Du2. Du2 means I can put one double bond inside. One ring, one pi bond. So I can say formula 1, 2, 3, 4. 4 carbons. Remember, when 4 carbons and Du matching, no need to see hydrogens. Automatically hydrogens will balanced. Okay. So that is the formula. Now, I am going to take C6H6. Generally, C6H6, it is benzene, but many organic molecules are possible to write with the help of C6H6. So, if you want to calculate Du, okay, here N is equal to 6 and apply that formula, alkane general formula. So, this is C6, 2 into 6, 12. 2 into 6, 12 plus 2, that is 14. Okay, C6H14. Here 6 and 14. Total how many hydrogens are differ? That is 8 hydrogens are differ. So I can say degree of unsaturation 4. Fourth degree of unsaturation. Otherwise apply this formula. Even that formula also will give the same answer. Degree of unsaturation 4 means you may create 4 double bonds. 1, 2, 3, 4, 5, 6. 4 pi bonds I can introduce. I can put one pi bond here, pi bond here, pi bond here, pi bond here. Yes, Du4 is matching. So balance with 2 hydrogens. Here no hydrogen, here 1 hydrogen, here 1 hydrogen, no hydrogen, and here it is 2 hydrogen. Balanced. Next, carbons remain same every time. 1, 2, 3, 4, 5, 6. 6 carbons are given. Now I can put one triple bond here. Every triple bond 2 Du. And one more triple bond I am introducing here. You can insert triple bond anywhere, your wish. So every triple bond 2 Du. Here also triple bond 2 Du. I can write one hydrogen here. Here 2 hydrogens. One hydrogen, one hydrogen, one hydrogen, one hydrogen, like that. So I can create even 4 rings. 4 rings are possible or not? See, this is 4 carbons. If I write here 6 carbons. 6 carbons are over. Du4 means 4 rings. But actually 2 rings are present. And write one more. So 1, 2, 3, 4. 4 rings, 6 carbons. Automatically Du matches. Okay. You can also write like this. See, 4 carbons, 6 carbons, double bond, double bond. 2 rings, 2 pi. 2 rings, 2 pi, 4. Okay. Then we can also create a pi bond and ring. See, 1, 2, 3 and this. Next, we can also create a 5-membered ring like this. 5-membered, outside one carbon I written Du4. Okay, so 1 Du, 2, 3 and this is 4. Fulvine, fulvalin, all molecules are generally belongs to this one, Carlson cases. Okay, next, suppose if I take benzene, 6 carbons are there. It is 1 Du, 2, 3, 4, matching. So it is one of the molecules. C6H6 nothing but it is one of the common molecular formula for all molecules. Don't think that it is belongs to only for benzene. Many molecules are possible to write. Okay, next. See, I would like to take one example regarding halogens. See, C6 C4H6Cl2. Now, when halogens are given, every halogen you need to assume as hydrogen, C6H8. You need to assume like this. Just now I explained. Every halogen is a hydrogen. So in C4H8, what is the N value? N value is 4. Substitute in alkane general formula. 2 into 4, 8. 8 plus 2? 8 plus 2, 10. 10 minus 8 by 2. 2 by 2. 2 by 2 means you will get 1. 1 degree of unsaturation. Apply in this formula even. Suppose if you are confusing, apply this one. Degree of unsaturation 2n1 plus 2 minus n2 by 2. Like this formula you can apply. Otherwise, alkane general formula, anyone you can apply. 2 into 4, 8 plus 2, 10. 10 minus 8, 2 by 2. 2 by 2 means degree of unsaturation is first degree of unsaturation. Which means, write down 4 carbons anywhere. Write down 4 carbons. Write down halogen. This formula. 2 chlorines I am writing. 2 chlorines. And here Du1 means 1 double bond. You can write any double bond. Anywhere you can write double bond. Now apply this and try to balance with hydrogen. Here 2 hydrogens are required. Here 1 hydrogen is required. Here 1 hydrogen is required. And here 2 hydrogens are required. See this? 2, 3, 4, 5, 6. 6 hydrogens, 2 chlorines. Okay. Next. C4H8N2. C4H8N2. With 2 nitrogens I am writing. Suppose see, in this every nitrogen remove 2 hydrogens. C4H6. It is only assumed formula to calculate Du. But while writing structure, you need to take this one. Now, C4H6, this one, degree of unsaturation, 2n1. 2 into 4 plus 2 minus 6 by 2. 8 plus 2, 10. 10 minus 6 by 2. 4 by 2, 4 by 2 means you will get 2. Second degree of unsaturation. So when you get second degree of unsaturation, and what are the possibilities here now? So write down 4 carbons, 1, 2, 3, 4. So second degree of unsaturation, first you write down nitrogen here, nitrogen. Okay. So 2 Du means you need to put 2 double bonds here. Put double bond, double bond. And here 1 hydrogen, and here write 2 hydrogens, and here 1 hydrogen, here 1 hydrogen, and here 2 hydrogen. See the formula? 2 Du is matching, 4 carbons is matching, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. But 2 nitrogens are present. So I can write any nitrogen over here. So I can write NH2. Anywhere you can write 2 nitrogens. You can write in open chain, ring, anywhere. But Du should be always remains constant. Okay. See this. 4, 5, 6, 7, 8. Okay. Next. C3H6O. Oxygen, one example I am giving. Suppose if it is C3H6O, every oxygen doesn't affect hydrogens, you will get C3H6 and apply Du formula 2 into 3, 6 plus 2 minus 6 by 2. 2 into 3 plus 2, 6 plus 2, 8 minus 6 by 2. 2 by 2 means what is the degree of unsaturation? First degree of unsaturation means you may expect 1 double bond. Write down 3 carbons, 1, 2, 3. Put double bond anywhere. So I can put double bond here. Write down oxygen anywhere. Then balance with hydrogen. This carbon carry 2 hydrogens. This carry 2 hydrogens. This carry 2. And oxygen definitely required 1 hydrogen. You can also create one more structure. See, write down 3 carbons. So I am writing one oxygen here. Du is what? 1. I can put double bond between carbon oxygen. This carbon having trivalency, put 1 hydrogen. And here put 2 hydrogens. And here put 3 hydrogens. That is the way. So this is the formulas which you need to concentrate on degree of unsaturation. Now see this. One more example I will give. This is Cn taken twice. Cn taken twice. What is the degree of unsaturation in Cn taken twice? Now, so generally this structure will be looks like this. Carbon nitrogen triple bond. And here also carbon nitrogen triple bond. If you observe this triple bond carry 2 pi bonds and this triple bond also carry 2 pi bonds. Total 4. This molecule carry 4 pi bonds. Now 4th degree of unsaturation. 4th degree of unsaturation. We can also confirm by using the formula. What is that formula? We know degree of unsaturation is equal to 2n1 plus 2 minus n2 by 2. See here nitrogens are present. We know that every nitrogen minus 2 hydrogens. So in this, how many nitrogens are present? 2 nitrogens. 2 nitrogens are present. 2 nitrogens means minus 2 hydrogens. But in this molecule there is no hydrogen. But if you apply in this formula, see in this case, 2 into, how many carbons are present? 2 carbons. 2 into 2 plus 2. So here hydrogens are not present, N2. Hydrogen is not present, but what I am saying is, every nitrogen minus 2 hydrogens. Just assume that here hydrogen is there, minus 2. I want to remove minus 2. Minus minus, it is plus. So here it is minus 2 hydrogens I want to remove, minus 2 hydrogens. Divided by 2. Then what happens, see, 2 into 2, 4 plus 2. 6. 6 plus 2, 8. So here 8 by 2 you will get, answer is 4. See, you will get this number, degree of unsaturation. Okay? Concept is very easy. Try to listen carefully and you will pick the answer very easily. Suppose if I give this molecule, this is double bond, here nitrogen double bond, and here nitrogen double bond like this. If you observe this clearly, what is the degree of unsaturation? So before calculating degree of unsaturation, first count how many carbons, how many nitrogens are present. In this 6 carbons are present, 6 carbons, and how many nitrogens are present? 1, 2, 3, 4, 5, 6. C6, N6. No more hydrogens. So I want to calculate degree of unsaturation. So apply du is equal to, formula remains same, N2 by 2. Now, here 6 hydrogens I want to remove. So I can write 2 into 6 plus 2 minus into minus 6 hydrogens. I can write minus 6 by 2. Same way. Here hydrogens are not there. N2 nothing but number of hydrogens. Minus 6 hydrogens I want to remove. Directly written minus 6. So then what happens? See, 2 into 6, 12 plus 2, 14. 14 plus 6, 20 by 2. 20 by 2 means you will get 10. So 10 degree of unsaturation means you will get 10 pi bonds or 10 possibilities. See, total how many rings? 1, 2, 3, 4. 4 rings are over. Then 5, 6, 7, 8, 9, and this is 10 pi bonds. So if any molecular formula is given, you are in a position to identify degree of unsaturation of a given molecule based on this technique. Okay, it may be any kind of molecule, you can apply the same one. Suppose if any halogen is present, you need to add number of hydrogens, then apply this formula, calculate du. Okay, suppose this is C6H5NO2. So suppose if mixed molecules are present, what is the strategy to identify degree of unsaturation? Okay, so first you need to convert only hydrocarbon formula. Here one oxygen is there. Oxygen never affect number of hydrogens. Every nitrogen, one hydrogen will be removed. So if I remove one hydrogen from here, you will get C6H4. So apply degree of unsaturation formula. 2 into N1 plus 2 minus N2 by 2. Then see degree of unsaturation. 2 into 6, 12 plus 2, 14. 14 minus 6, 10 by 2. 10 by 2 means you will get 5. Fifth degree of unsaturation. Nitrobenzene, best example nitrobenzene. See, nitrobenzene, I can write 6 carbons here. Double bond, double bond, double bond. And here this is nitrogen. Here double bond O, here O minus, and this is plus. One ring, 3 pi bonds. Here pi bond, pi bond, pi bond, here pi bond. 4 pi bonds, 1 ring. 4 pi bonds, 1 ring means fifth degree of unsaturation. So that is a way to calculate degree of unsaturation in a given molecule. I will show one more example, just listen. Suppose if I take pyridine, this is pyridine. In this 5 carbons are present, 5 hydrogens are present, 1 nitrogen is present, right? C5H5N. And if I want to convert them into this nitrogen, remove 1 hydrogen. So C5H4 you will get. C5H4. Apply degree of unsaturation formula. Degree of unsaturation 2 into 5 plus 2 minus 4 by 2. So then what is your answer? So 2 into 5, 10 plus 2, 12 minus 4, 8 by 2. So you will get 4. Fourth degree of unsaturation. See this? 3 double bonds, pi bond, pi bond, pi bond, and 1 ring. Like that. So you can also calculate directly by watching this molecule. See, in this, what is the degree of unsaturation? Degree of unsaturation in this molecule. 2 double bonds, 1 ring. So third degree of unsaturation, like that. Okay. Suppose if I take naphthalene, what is the degree of unsaturation of naphthalene? Pi bond, pi bond, pi bond, pi bond, pi bond. So 1, 2, 3, 4, 5, 6, 7. So 7th degree of unsaturation. Because 5 pi bonds are there, 2 rings are present. Suppose if I take anthracene, double bond, and double bond like this. First count total number of pi bonds here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10th degree of unsaturation. 3 rings, 7 pi bonds. 3, 5, 7. 7 plus 3, 10. 10 degree of unsaturation here. 5 plus 2, 7. 7th degree of unsaturation. So that is a way of calculating degree of unsaturation in a given molecule. With the help of degree of unsaturation, we can easily confirm whether given molecule is a satisfied molecule or unsatisfied molecule. Just make a short revision. This is generally degree of unsaturation, also called ring rule. We can also write some rings, sometimes without rings. The unsatisfaction of any organic molecule is du. One du nothing but degree of unsaturation nothing but molecule may carry one pi bond or one ring. Pi bond or ring. Right? They may carry one pi bond or one ring. Suppose if I say double bond carry one pi bond. Triple bond carry 2 pi bond. So every saturated molecule is generally we are going to consider as alkane. Every unsaturated molecule want to become an alkane only. The number of hydrogens generally less than alkane general formula is du. So this is the formula. If 2 hydrogens are less than 1 du, 4 hydrogens are less than 2 du, then we can also go through 3 du, 4 du like that. So you can also use this formula. N1 nothing but number of carbons, N2 nothing but number of hydrogens. Every halogen add 1 hydrogen, every nitrogen remove 1 hydrogen. There is no effect of oxygens. Use these examples, and these are the examples. C2H4 means separate this carbon number. Write down N. This N you need to substitute in alkane general formula, you will get a real formula. It is a saturated formula, it is unsaturated formula. Try to see the difference between number of hydrogens. 2 hydrogens are less, so that's why 1 du. 1 du means 1 pi bond or 1 ring. So between 2 rings I can't write 1 ring, that's why I'm ignoring this. I'm writing only pi bond. So like that we can go through certain examples with C3, C4, C6. So benzene generally you people think only benzene. C6H6 is not benzene. Multiple organic molecules are exist with this formula. Okay. Every time you remember only one point. If you know degree of unsaturation and if you know number of carbons, automatically this total number of hydrogens will balanced. No need to count. If it is not balanced means you people done some mistake somewhere else. Okay. So like that I given certain examples, especially chlorine, nitrogen, oxygen, then followed by cyanogen. How to calculate degree of unsaturation if they given properly. So few examples are given, and if some molecules if they given directly in the form of rings, we can also calculate degree of unsaturation. Okay. So that is about concept of degree of unsaturation and ring rule. These concepts are most helpful for hydrocarbons as well as and their derivatives, especially for IIT advanced examination as well as mains examination. It is one of the most important formula and one of the important aspect to determine the structures of organic molecules, and we can also confirm the isomers with respect to that molecule. Hope you will understand. So try to share this video to your friends. Try to subscribe our channel so that you will get new videos regularly we are uploading, and that videos will get in the form of notification. Thank you. Thank you for watching.